Hi Alex, how are you?
I'm doing well. How are you?
I'm very good.
Excellent. Are you ready about learning how to systematically design methods?
Yes, I'm so ready.
Excellent. Before we get started, should we go in and talk about what we learned last class?
Yes, sure. We in the last class we learned that how to calculate, how to convert actually manual calculations into automated methods in a Java class. So, for example, we converted a person's weight from kilograms to pounds
Mm-hmm.
with a method called convert to pound,
Mm-hmm.
and we also did another example with the BMI index.
Yes, exactly. We did learn all of those. And I think what we also learned is local um, variables. So if you remember, we needed to convert our height to meters. So when we had the height in meters, we set a variable to be height in meters so that we didn't have to, um, I guess, we didn't have to calculate it twice.
Exactly, yes.
Awesome. Excellent. So, once again, if anyone watching, if they have any questions or if they're not sure about all of these things, feel free to go and watch the 1.2 video. And we also went over our homework from last class as well, so you can also watch that. All right. So let's get going to the next chapter, systematic method design. Once again, everything is available on the AP Computer Science Done Right book, which people can get um, on Amazon, either the Kindle version, the ebook version, or the hardcover version. All right, let's get going. So, Irfan, I don't know if you know this, but an average woman typically eats about 2,000 calories a day. Um, and
Mm-hmm.
imagine that in a class, in our information class, food, we want to indicate how many calories an instance of food have. So, for example, if you eat an apple, how many calories does it have? This is going to be helpful because if someone eats 2,000 calories a day and then they eat something that's 100 calories, they want to know what percentage of their daily calorie intake have they eaten. So, for example, if a banana has 150 calories and I can eat 2,000 calories a day, I would do 150 divided by 2,000 and then multiply it by 100 since it's a percentage,
Right.
and it will be 7.5%. So eating one banana is
7.5.
7.5%.
Mm-hmm. Right,
Exactly.
yes.
So we want to design this percentage calculator, this method. How do we design things systematically? Once again, Erfan, this is about what makes a great programmer to a mediocre programmer. A mediocre programmer will just think about, like, okay, how do I do this so that it works? So that when I give it the input, it will give me the right output. But great programmers know programs are made for humans, and humans need to actually read the program. So it really matters um, how you design your methods. So we're going to
Right.
start with, this is super exciting, so I'm going to choose a different color. Design recipe. I guarantee you, if you follow the design recipe, you will have amazing programs. And if you follow the design recipe at like a technical interview, you are good for the job. People are super impressed with the design recipe. So,
Fantastic. Let's see.
yes, let's do it. Let's see how it works. Okay, The very, very first thing that you must do in the design recipe is the purpose statement. Now, the purpose statement isn't just, writing the name as a sentence. No, it needs to convey information that's more than just the method name. So, for example, for our method here, our purpose statement might be what percentage of the daily intake does this food represent? Does this, remember classes are with capitals, so we always have a capital, food represent. This looks long here, but I'll promise you it's shorter when you're actually programming. The reason why you have purpose statements is that, for example, if you're in a job and you have thousands and thousands of lines of code and hundreds of different files and everything, it's super easy to try to go through the methods, and just read the purpose statements and quickly understand, okay, this is what this is doing, great, let's move on. If you had to read every single line of code and understand everything, that will take you hours, and that will make your development time or your testing or debugging time to take so much longer. So this is why we always have purpose statements. They may look silly when you're writing them now, but the future you will be so thankful if you write them. Does that make sense?
Yes, makes sense.
Excellent. So now we should talk about what class should this method belong to. We have the class person, and we can also have a class food that has a bunch of information about food. So what should our where should our method be? In the person class or in the food class?
I think in the food class.
Okay. Why do you think it should belong in the food class?
Because it's going to have an intake for the food.
Mm-hmm.
So it's in the food class.
That's a great way to distinguish it. Yes, absolutely. All it needs is about the food's calories. So the person doesn't have like a daily maximum necessarily, but the food following this formula, the food class will have a calorie count. So we want to make sure that it's in the food class. Okay, excellent. So that's the first step, purpose statement. Are you ready for the second step?
Yes, absolutely.
Excellent. The second step is called signature, which is essentially the input and output. So the way that Java works is that it typically has the output first. So we have the output as a keyword, and then we have the name, and then inside the parentheses, we have whatever input. And then the method starts. So for this example of percentage calorie count, what output do you think we should have?
It's a double because it's a percentage.
Exactly. It's going to be a double. And what about the input?
The name, you mean? The name of the double?
No, so the name is going to go in here. The input is what we need to pass into the to the method. And since
right.
Yeah, so since everything can just use this food's information, we can actually leave this blank. There is nothing else that we need to put in as an input. It's just about the food, and the food already exists in our the food information already exists in the fields, so we don't need to pass it in. And then we need to have the name. So I think a good name would be calorie percent point. Calorie percent. I'm going to move these guys along since they're so there's no input just yet. We'll have more examples of methods that have an input, but for now, we can just have this. So this is our signature. The output type is a double, the input type is nothing, and because it exists in the food class, it will have access to all the food information. Does that make sense?
Yes.
Excellent. Step 3. Step 3 is examples. This is a super, super important step and one that a lot of people usually skip, but that's when you write code with bugs and with problems. You always want to have examples because you want to make sure that you actually understand what the method, needs to do. So similar to the beginning where I gave you an example of a banana, we can do another example as well. Irfan, if I recall, you are a fan of chocolate milkshakes. Are you not?
Yes. Yeah.
Excellent. So I think chocolate milkshakes are about 450 calories, which I don't think we knew when we had that many. And so 450 calories, and let's say I am expected to have 2,000 calories a day. How do I calculate my percent point for a chocolate milkshake?
So it's 450 divided by 2000 times 100.
Exactly. And that gives about 22.5%. Does that make sense?
So
Yeah,
yes.
that is bad. Like 4 chocolate milkshakes, and I basically can't have even a banana. So it's quite bad. All right. The next step, drum roll please, is code. So see that 1 through 3, we still haven't coded. Only in the 4th step are we actually going to code.
Yes.
Yes.
Interesting.
Exactly. So the code will start with actually step 1, you will have your purpose statement. And then step 2 of the signature, that's actually our first line of code. So we can just copy that and say double calorie percent point. Takes in nothing. Open brackets. All right. Now that we have our example, it's fairly easy, right?
Yes.
Okay, so what should our what should our method body look like?
So it should start with a double. This is the percentage again.
Yeah.
We can call it percentage, the name of it.
Perfect.
Gets us these, the calories, because we already have the information.
Exactly.
Divided by 2000.
Perfect. All right. So now we have this part. Then what do we do?
Yes, so we want the Java to return us, so it was return.
Exactly. We're expecting a return.
Percentage again. Times 100. In the previous line, we already calculated it, and then we multiply it by 100, and then it's a percentage.
Perfect. Yes, exactly. And we just have a closed braces. That's exactly how we should do it. So we know that we want to split things up so that we don't have one thing in like one giant line. That's not good. We need to have limits on our lines. So we want to have the percentage calculated, and then we just multiply by 100. This is also like really clean, easy to read. You can easily see what it's doing. So if you make a mistake, super nice and easy to change.
Exactly.
Excellent. Okay. Now, one thing you might notice is this method only works if your daily calorie intake is 2,000. However, for example, you or Fawn will have a different daily calorie intake. You might have around 3,000, let's say, correct?
Okay, yes.
So it wouldn't make any sense to just like have a bunch of different methods that are essentially the same, but just have this bit of information different, right? Like that doesn't sound clean. So instead, we want to write a method that can take in whatever and whatever number and calculate it all the same. So how can we do that? Well, remember how in our signature we said the output is going to be a double and the input is nothing? Well, what if we add this guy as our input? What if we add in the daily calorie as our input so that it can calculate this based on this? How does that sound?
Sounds very interesting.
Yes, it does indeed. So then, when we had double, what's the name? Oh yeah, percent point, calorie percent point.
Yes.
Calorie percent point. Instead of an empty parentheses, we can say take an int of daily calorie. Then it's simple. We just need to change this line right here. So we say double percentage to be this dot calories divided by this guy.
Daily calories.
Yes. And then this stays exactly the same. So we just return percentage times 100. Does that make sense?
Yes, it's perfect.
Yes. So now we need to also change our purpose statement. So remember, in our purpose statement, initially we said, what percentage of the daily intake does this food represent? This should actually say, initially it should say based on a 2,000 calorie intake.
Right.
But now, this purpose statement is actually more accurate. Now we can say with the given calorie intake. Does that make sense?
Exactly. Yes.
Okay, excellent. So now that we have this, we can call this by saying, let's say, create a new. So we want to go through our example. So our shake gets new food, and the food class requires a name and a calorie. Milkshake, 450. And then we just say shake dot calorie percent point. And let's say we're talking about someone who can have 2,500 calories per day.
me clarify, please.
Mm-hmm.
Can you tell me why do we write shake that's calorie?
Because we want to reference this. So we have a class food, and it has a string name, and it has probably an int calorie,
Right.
and it has probably a constructor. So that's how this is getting made. So imagine there's a constructor here too. Then this method that we just created is inside this class. So it's going to be here. So it's going to be double calorie percent point and daily calorie. So whenever you try to access a method, anytime you want to call it a method, you first need to say the class that you're the object, the instance of the class that you're uh, gonna call. So similar to how before we had the paper plane class, and we did like paper plane, like Erfan's plane gets like whatever new paper plane, whatever.
So it's new what we were talking about.
Yeah, so it's new whatever class that we are creating, new paper plane. And then we gave it all the examples. If we want to call a method on this, we have to call Erfan's plane. Plane, let's say dot convert to string, let's say. So here's the way to think about it. This is a great question, actually. So when you have a class of something, let's say class X, you're saying I have a category of these things. So I have a category of food. I have a category of paper planes. I have a category of whatever. And then inside of this, you have a bunch of examples of these categories. And we call these examples objects or instances. Instances of X. Okay?
Okay.
So, for example, if it's class food, a strawberry is an object. It's an instance of food. Okay?
Correct.
And when you want to call a method, you have to call it on a specific object, on a specific instance. Because if you call it like on a category of food, the food is like, I have no idea what calorie I have because I can have any calories. I can have a number of different calories. But if you say, no, I want to know the percentage point of a banana, then it says, oh, okay, this specific food that you want, this is a method.
Right, exactly.
Does that make sense? Because remember, in the constructor, that we, how we say like this dot calorie gets like whatever calorie that we have passed in. The constructor only works when you make a specific example, when you make a specific object. There is no constructor for the entire class. The entire class can have anything.
Now I see, yes.
Does that make sense?
Thank you, yes. Makes perfect sense.
Okay, excellent, perfect. So that's the code. And really, when you have done steps 1, 2, 3, step 4, which is coding, should just come naturally. Like it's really easy to write it because you have the purpose statement, you have the input and output. You have a signature, um, and you have an example to go through. So the code will just kind of come naturally. But this is where good programmers will take it a step further, the great programmers, I should say. And that is testing. Irfan, I can guarantee you many programmers, when they write something, they have made a mistake. They have created a bug. We call mistakes in programming are called bugs.
Right.
Yeah. So when you want to figure out your mistakes, we call them debugging.
So a lot of programmers have bugs in their codes.
Exactly, they do when they first write it. The way to make sure that you don't publish code with bugs is you write tests. So, the test should be different to your examples, because you want to make sure that you are actually correct in whatever you decided. So let's say we want to add a test that test for let's say an apple, and apple for someone who takes 2,000 calories per day. Actually, not an apple. Apple is not exciting. Let's do chocolate. Okay, great. So if you want to do this as an example, you first say, okay, we expect, and this will be different in each IDE. So we'll go through the homework together with the IntelliJ IDE. But essentially in any IDE, you expect so we had food, chocolate to be new food, chalk, let's say. And it has, let's say, 450 calories again. Okay, so we expect chocolate the calorie percent point of 2,000 calories to return approximately, because these are doubles, so
Right.
Yeah, to return 450 divided by 2,000 multiplied by 100. So since we've added a parameter, we should also test it with a different parameter. So let's say test 2, chocolate for 3,000, let's say, calorie person. Then we expect chocolate dot calorie percentage point of 3,000 to return approximately, so 450 divided by 3,000 multiplied by 100. Yeah. Okay. Does that make sense?
Yes, makes sense.
Um, so now that you know about testing, we should never use the print line for manually checking, oh, yes, this is the right answer or not. Because print line is a manual project, and we're programmers, we're developers, we want to automate things, we want to make things as fast and as efficient as possible. They're not the same as testing. So now that we know, printing is not testing. This is the main thing. But we're going to learn how to test in our IDE as well.
Okay.
Perfect.
Makes sense.
Excellent. Just one last thing. When a test fails, it could mean a few different things, and it's important for us to know. So it could mean that the method body is wrong. So for some reason, we have created a bug in our program when tests fail. It could also mean that the expected value is wrong. So the expected value that you're giving it should actually be different. Expected value is wrong. It's wrong. And then it can also be both the method body and expected values are wrong. Now, unfortunately, sometimes the test will incorrectly pass when both the method body and the expected value is wrong. So it's really important to take your time with the tests and have a second pair of eyes to make sure.
Right, that's very scary.
Yes, exactly. But I think for the most part, I have full faith that people will write good tests and they will write good programs as well. Does this all make sense?
All makes sense.
Excellent. All right. Are you ready for the homework?
Yes, let's go for it.
Excellent. All right. A friend of ours, Ehsan, just recently learned that an average person should consume 3 liters of water per day. That's quite a lot. Now, Ehsan has a wife, children, and 20 grandchildren. And he says that he can fill an Olympic-sized pool, assuming 80 years of life for each individual. So, what he wants to do is to build a pool in his backyard and just drink from the pool instead of all these plastic water bottles. He's really into saving the environment for some reason.
Wow. It's very impressive.
Exactly. So what we want to do is design a class that represents the pool with its dimension. And then once you've designed this, you want to add a method that calculates its volume.
Okay.
All right. Does that make sense?
Yes, it's perfect.
Excellent. Once you do this, the second problem is add a how much left method to the pool class that takes in a person's age and determines how much water should be left in the pool for this person for the rest of their life.
Right.
Does that make sense?
Yeah.
Excellent. And then the last bit of homework we have. So Another friend of ours, Zala, hears about Ehsan's idea and gets a similar idea for watering her plants. She writes a following code, which I will screen share here. Um, and then you ask for a test. Let's skip this one. It's too hard to. It's too hard to put it in a video, and it's like not as helpful.
Okay. Just want to take it together because you remember I asked you this. You told me
Yes.
we're going to do it in homeworks.
That's true. That's true. Okay. So for the third problem, let's take a look at the book together. Boom, right here. Let's see. Uh-oh. Oh no. 1 second. Kujola? Okay.
این کلیه که نوشتم.
Yeah, exactly. Okay, so for the third problem, let's look at this code. So Zala, who has heard about Ehsan's idea and has a similar idea for watering her plants, she writes this code. First of all, she starts with a purpose statement, which is great. When to water her houseplant, how much water to use, and then she shows you this for a test. So watering day, next day, she has 5, and the next day to be November 25th. So what's her mistake here? This is the question here. So take a look at her code, go through the designed recipe, and think about where did she make a mistake so that she can be your friend and she'll pick you for gym class.
Of course.
All right. Any other questions?
Nope, it all makes sense. Thank you for your time.
Thank you. Have a great day.
And you too, bye-bye.
Bye.